irrational? That this is the question, this is the problem. So in this case you will think there is a number which is √2, so it is your P, and then it will be irrational. This is your Q. So in the contradiction system, what we do, we try to prove P implies not Q is false. This is our target. So we will try to do that. Or false means in this case we actually show that this is a contradiction. So contradiction means we are thinking of something but we are getting something else. Okay, so we started something but finally we are coming to something different. So that means there is a contradiction. Okay, so what we do here, so we start with P. That means we are taking the number √2, okay, on our hand. So we will think like that. Okay, so say √2 is a number. This is just a number. This is our P, and we are saying that not Q. Not Q means it is not Q means it is not irrational. Let us assume it is not irrational. That means we are checking if it is not Q, then what happens? So not irrational means √2 can be written as a ratio of two numbers. Say, let me write x, y. Okay, x and y are two numbers. So x are two numbers. What type of number? Numbers are x and y are possible smallest relative prime. So this is the main thing actually. We do not focus on this part, and that is why misunderstanding comes. So x and y are not any type of number. These are the numbers which is possible smallest and which is relative prime. So what is relative prime? Relative prime means they will not have any common factor. No common factor. So no common factor means you cannot do any more cancellation. Cancellation means you cannot cut by 2, cut by 5, like that. Okay, cut by 3, something like that. Say, let me give you example. Say one number is 20, another number is say 34. So what happens? You can just cancel by 2. So you can cancel by 2, it is 10, and then 34 is 17. So now it is 10, 17. So these are possible smallest relative prime. So can you cancel any more? Can you cancel any more for 10 and 17? Not really, not possible. So individually 10 is not a prime number, but they are relatively prime number. Relatively prime number because there is no common factor in these two numbers. So x and y will be something like this. So if you want to say x by y, that can be 20 by 34 also. This is x by y, but we are not taking this x by y. We are taking 10 by 17. That x by y we will take. This one will not be taken because we want to take which is smallest relatively prime. So now after this line, you just go to the next line and you do the square in both sides. So if you do the square in both sides, it will be 2 in the left side. So in the right side, it is x square by y square. So you can write 2 into y square because you can just take it in the left side, and 2 in only x square is in the right side. So this one is x into x on the right side, and there is something 2 into y square. Okay, so if you think that this one 2y square, this one is actually an even number, isn't it? So there is a 2 factor. There is a 2 factor because you can see easily 2 into something. So whatever into, that means 2 into something means you can divide it by 2. So if it is possible, you can divide it by 2 the left side. So you can also divide it by 2 for the right side. That is also possible. So you can write in the next line x square is divisible. Divisible means can be divided. So divisible by 2. So if x square is divisible by 2, then then uh, also x, that is only x, is also divisible by 2. So I mean, it is obvious because say something is 5 square, so fine. Something is 15 square, so fine. Square number means 5 into 5. Square number means same number 2 times, isn't it? So if 15 square is divisible by 3, then 15 is also divisible by 3, otherwise not possible. So everything will be 2 times, 2 times 3, 2 times 5, something like that. So in this case, x is divisible by 2. So you can write maybe x equal to 2 into k, possible. So if it is x equal to 2 into k, you can go to the next line. You can write, okay, this is 2y square equal to uh, 2k whole square. So 2k whole square means 4k square. So it is actually y square equal to 2k square because 1 2 is cancelled. Okay, 2 and 2 cancel, so another 2 is on the right side. So it is again in the same situation, that is y square equal to 2k square. So again you can say this is divisible by 2, so y is divisible by 2. So in that way, in the same logic what we have applied here, if we continue with y also, we can write, okay, so the same thing like y also is also divisible by 2. So when we come to this decision, that is actually not possible situation. Why not? Because if x is divisible by 2 and also y is divisible by 2, that means you can cancel x and y by 2. So why didn't you cut this thing by 2, x by 2 and y by 2? Because it is written they are relatively prime, so they will have no common factor. So it is not really possible. So it is actually false. It is actually contradiction. So which one is contradiction? If we take not q on the right side, p is the thing, that is root 2 is a number. It is our p. It is taken. But if we think this is not irrational means rational. Rational means not q. So not Q, it will give us a situation which is never possible. Okay, so this is a contradiction. You can write, okay, this is not possible, or this is a contradiction, or this is always false. Okay, in that, after writing this, you can write, okay, so we thought that root 2 is not irrational and it is actually a contradiction, so it is irrational. That is correct. So this is how you prove this theory. Okay, I'm just talking a little quickly, so I hope you understand this. Is that okay? Do you understand now?
Yes, sir.
Okay, so let us finish this here and go to the permutation chapter, what is our regular topic today. So we talk about counting principle first. Okay, so counting principle. So in that counting principle, actually what we talk about, or what we consider, it is like, let me make it a little bigger. So it is like, in the counting principle, we say that sometimes we add and sometimes we uh, multiply. So there is a product rule and there is a sum rule. So what is product rule and sum rule? Say I'm giving you one example that will be easy to understand. Say uh, you have a party and some friends are here, so you have some options like there are three three types of uh, say juice, three types of juice. Okay, and two types of uh, tea. Okay, two types of tea. There are uh, four types of snacks. So maybe biscuit, maybe somacha, okay, maybe shingara, something like that. So there are four types of snacks. So you are saying you are saying that you are saying that this is your offer, so you can take any one drink. You can take any one drink. So how many options you have? What you will understand? You can take any one drink.
Uh, there
So
I
how
have
many?
9 options where some options are repeating.
Three types of juice.
So how many options you have?
So
Three
9 options where some of the
No,
options are
no, no,
repeating.
no. Drink, snack is not a drink.
Oh, so sir, 5 options.
five options.
Five options. So you were actually adding, isn't it? You were actually adding three and two. So you are actually applying sum rule. Why sum rule you are applying? Why? What is the connective here? What is the connective?
Sir,
Actually, the
drink, sir.
connect. What did you say?
Sir, drink, sir. Drinks is the
Yes.
connect.
No. Drink is not the connective. Drink is two types of things, juice or tea. So,
Yes, sir.
logical expression. What is the connective here in this case? The connective is anyone.
And sir,
No, not and.
or
Someone will take
sir,
juice
sir, or
and
sir,
tea. No,
or
someone
sir.
will take juice or tea. Okay, juice or tea. So in this case, it is It is actually or, juice or tea. It is actually or here. So when we connect two things by
Sir.
or, that is sum rule. And in also Boolean algebra, or means plus, right?
Yes, sir.
Every time you know or means plus. So that is the understanding actually. This is the sum rule. Okay. So let me tell you another situation. Okay.
Sir, since it says any one, like
Hmm.
I can, in case of or,
Sir,
I can take both,
sir, if
either
Right.
or.
or condition, then we can take only one. I think if juice or tea, we cannot take both of, right?
Right.
So,
So
it should be X, sir,
Yeah,
or
sir.
yes. So in most correct situation, you can say it should be X
either
or
juice or
either juice or tea. That is okay. That is true. But in simplified form, just simple form, we are not considering that thing. We are writing okay any one drink. Okay, you can take any one drink. So everybody will understand either juice or tea. So this is generally we call or is actually sum rule or means addition here. And let me take you to another example. Here I am writing, uh, okay, you are offering to your friends. Okay, you can take uh, one snack and one drink. Sorry. Or say or say one snack and tea, just something like this. Then what will happen in this case? In this case, is it 6 or 8?
Sir, here we can take one snack. Snake. So here have four types. Four types. So and we drink tea. It is two types. So snacks is four and tea is two, not six. Sir.
Then what is your options? What is your answer? Not 6 means what? Then what you calculate? 4 and 2 multiplication,
Yes, sir. It is product's role.
product rule. So, sorry, you are actually right, but how you are right? So, let me explain. So, let me think that there are there are two types of teas. So, one is milk tea. Say we are thinking one is milk tea, another is raw tea. Okay. So one is milk tea, another is raw tea. So MR. And there are four types of snacks. So one is singara, okay. One is biscuit, one is puri, and one is what? Say fruit. Okay, say fruit. Okay. So there are four types of snacks available. One is shingara, one is biscuit, one is puri, one is fruit. Okay. And two types of tea. One is milk tea, one is raw tea. So you can now just think somebody is taking milk tea and shingara. Possible. Somebody is taking milk tea and biscuit. Possible. Somebody is taking milk tea and puri. Possible. And somebody is taking milk tea and uh, fruit. Okay. Another person uh, who is choosing roti and shingara, or roti and biscuit, or roti and puri, or roti and fruit. Possible, right? So in this way, actually, total options are coming as 8. 8 means 2 into 4. 2 into 4. So if you take milk tea, then 4 options. If you take raw tea, then again 4 options. You understand my point?
Yes, sir.
Yes, sir.
So in the AND situation, we use multiplication. That is also already known to you. This is called the product rule. So you just keep it in your mind and it will be used. In permutation combination concept, it will be used many ways. So this is the example about product rule, sum rule. Now I will move to the permutation concept. Is that okay?
Okay, sir.
Okay. Now let me talk about permutation. So what is this? Another thing is very important, combination. So two important things, but we cannot talk both in one class. So today I will talk about permutation only. So let me write it down. It is called permutation. So what is this actually? The topic is, let me give you example that will be better to understand. Say you have 3 letters A, B, C. Okay, say A, B, C, 3 letters, and you have two places where you will choose a letter for that. So you choose a letter for the first position. You can choose A, or you can choose B, or you can choose C. So you put this letter here. Okay, maybe A, or maybe B, or maybe C, anyone. So how many options you have? You have 3 choices. You have 3 choices because you have 3 letters. So you can choose anyone. You can choose A, or you can choose B, or you can choose C. So they are added together because these are or. You can take A, or you can take B, or you can take C. So this is also XOR situation. You cannot take two things, either A or B, either B or C, like that. But we are just saying only or. We are not saying XOR for simple understanding. So these are plus plus plus. One option plus another option plus another option. So altogether 3 options. Fine. Now after choosing this first letter, now you will go to the second position. So when you go to the second position, there will be 2 options. There will be 2 choices. Why 2 choices? Because one
So
is
because
already
we already choose one for the place one.
right. So we have already taken one. So we have 2 others. So which one you have taken, we do not know. So maybe A is taken. So you have B and C now. If you have B taken, so A and C now, like that. So you have 2 choices. Now the the total choices will be 3 into 2. In this case, the total number of choices will be 3 into 2. So total choices for taking 2 letters from 2 letters from a list of 3, okay, is 6. So how this 6 is coming? This 6 is coming by multiplying 3 into 2. 3 into 2 multiplying by that. So 3 choice, 2 choice, that is actually 6. So we are getting this 6 like that. Okay. So why it is AND? Sorry. Why it is AND? Because you have to fill up both of the boxes. You have to fill both box. You got my point.
Yes, sir.
You have to fill up the first box and also the second box. So between the box, this is AND, this is AND. So you are taking two things, like one snack and one tea, like that. So you have to fill up this one and also this one. So and so multiplication. Okay. So we call this, what we have written here, we call this matter permutation. This is called permutation. And it is written like 3p2. So
So, sir,
3p2, yes.
taking A, B, and BA are considered as two different choices.
Yes, yes. This is good question. So I will talk about that. So let me just finish the formula writing, then I will go to that. So okay, formula I'm writing later, no problem. So what are the things actually? Here the things are A, B or A, C or B, A or B, C or C, A, then C, B, like that. So these are the 6 things we have got. So this 6 means these are the 6 arrangements, 6 different arrangements. So when we talk about 6 different arrangements, we see AB is one arrangement and also BA is another arrangement. So this is another understanding in permutation. The order is very, very important. Order is important, like which one is first and which one is second. This is important. So we have to fill, that is taking two. Taking two means not at a time. Taking two means not at a time. We are taking two one by one after another. One by one is a very important thing. So when we take one by one, that means it is important which one is first and which one is second. So AB and BA will be different counting. AC and CA will be different, and BC and CB will be also different. So there are 6 arrangements here. Okay. So let me write the formula now. What is the formula? Formula is NPR is equal to factorial N divided by factorial of N minus R. So this is the NPR formula. So you can just memorize this. This is the formula for permutation. N is the number of items you have, and R is the number of choices you are taking. So number of boxes, you can think number of place. Okay. So in this case, if you want to check what will happen for 3p2, so that will be actually factorial 3 divided by 3 minus 2 factorial. So 3 minus 2 factorial is only 1, and factorial 3 means 3 into 2 into 1. So it is 6. So this is the calculation by formula. Okay, and this is the understanding. And you can check with, say, 5p3. What will happen with 5p3? This is formula will be factorial 5, and it is 5 minus 3 factorial. So it is factorial 5 by factorial 2. So factorial 5 actually what? 5 into 4 into 3 into 2 into 1, right? And factorial 2 in the lower side, that is 2 into 1. So 2 into 1 cancel. It is 5, 4, 3. So it is 60. If you think about 8p4, so what will happen with this? It is again factorial 8 divided by 8 minus 4, 8 minus 4 factorial. So 8 minus 4 factorial is actually 4 factorial. So it is, you can think, okay, it is 8, 7, 6, then 5, then 4, then 3, then 2, then 1. And in the lower part, 4 factorial. So it is 4, 3, 2, 1. So 4, 3, 2, 1, 4, 3, 2, 1, cancel. So you have 8, 7, 6, 5. So 8, 7, 6, 5 will be what? 1680. Like that, you can check. So it is 8p4. Okay. So what we can see, another thing here, what we can see, every time actually you are cancelling the 4321 4321 or 2121, like that. So you are having only this part. This part means 4, no, not 4. Okay. 4 is not included. 8764. This part means you have only 4 numbers included. So 4 numbers included means you start from the original number, the big one, and you write the lower number of numbers one by one. So it's like that. You can think 8p4 is actually 8 into next number 7 into next number 6 into next number 5, and then finish. So how many numbers you are writing? This is the lower number, that is 4 numbers. 4 numbers you are writing here, and you start from 8. So in the same way, if you think about 5p3, the earlier one, it is like 5 into 4 into 3, and that's it. So in the same way, you can find out other example. Say one is 10p2. One formula we need to know, it is 10p2. So what is 10p2? 10p2 will be
10 into 11 into?
no, not 11, one less.
Sorry, sir. 10 into 9 into 8.
No, why 8? Because there is 2 only 2 number. So 10 into 9, finish. Okay. If you need 11p3, then you will write 11 into 10 into 9. That's it. Finish. Done. You got my point?
Yes, sir.
So this is how you handle the formula. This is how
This
you
is very
handle.
easy, sir.
Okay, so this is how you handle the formula. Okay, so you are saying it is easy. Fine, I'm happy to know that it is easy. Actually, it is
আমি
easy,
কখন
but
চিন্তাও করে দেখি নাই।
okay. So this is the formula handling. Fine. So this is done. Now, quickly let me show you one example, two example. Then tomorrow I will also talk about this again. So let me just give you the example like, okay, in how many ways the 5 vowels can be arranged by taking each letter only once. So this is one question. Okay, and let me give you another question. Say how many 4-digit numbers can be made by using 2, 3, 4, 5, 6, 9. Okay, 2, 3, 4, 5, 6, 9. Okay, taking each digit on once, just once. Okay, or only once. Okay, so this is another question. So these are the two simple question, very simple question I'm talking today because I do not have enough time. So we will do some more problems tomorrow and then talk about combination. So this is the formula you already know. So these are the permutation situation here. These are the permutation situation, and what will be the first one? So let us think about first problem. In how many ways the 5 vowels? 5 vowels are what? A, E, I, O, U. So these are the vowels. So you already know there are 5 vowels. So A, then E, then I, then O, then U. So they are the 5 vowels. So all of them will be arranged. All of them, because it is said all 5 vowels will be arranged. So fine. So it will be 5 letters are there already, and you will take all 5 letters. So it is actually 5p5. So 5p5 means what? 5p5 means 5, 4, 3, 2, 1, everything. So it is actually factorial 5. So factorial 5 will be what? 120 maybe. Okay. So this is the first answer. Second answer is there are 1, 2, 3, 4, 5, 6. 6 numbers. There are 6 digits. Okay, say 6 digits, and you will take 4 digits. You will take 4 digits. So there are 6 digits. You will take 4 digits. So that means from 6 you will take 4. So 6p4. So one number can be 2345. Another number may be 2356. Another number may be 2369. So in this way it will go like that. So how many numbers possible? So numbers possible: 6, then 5, then 4, then 3. That's all. Four numbers serially. So it is actually 30. 4 into 30, 120, and 3. So it is 360. So 360 different numbers will come. So they are the 360 numbers. Different numbers will come. Okay, 360 numbers. So this is the question. Okay. Now, if I give you one more thing, if I give you one more part of the question here, it is like how many of them are even. So this is another question, another part of the question. There are 360 numbers. It is true. But how many of the 360 numbers will be even numbers? So how do you know about that? How many of them will be even number? So for that part, you will also consider that the last digit must be
Even.
2 or 4 or
6.
2 or 4 or 6, because in these options you have 2, you have 4, you have 6. So the last digit, so there are 4 places, 1 and place number 2, place number 3, place number 4. So if the last place is 2 or 6, then you can say this will be even number. Okay, so how many ways the last place will be 2 or 4 or 6? This is 3P1, because you are taking one number here and you have 3 options. So it will be 3P1, and then other 3 places will be filled up. So now you change the serial. So you will fill up the last place first, and then you move to the other 3 places. So how many ways the other 3 places can be filled up? So that will be 5P3. Why 5P3? Because there will be 5 options. One is already taken here. So maybe 2 is taken. So 3, 5, 9 and 4, 6. So 5 options here. So 5P3. And then you multiply. Then you multiply. So the final answer will be 5 into 4 into 3. So it is 5 into 4 into 3 means what? 60. 60 and then 3. 3P1 is what? It is 60 and 3P1 is 3. So it is 180. So 180 will be the even number. 180 even numbers. So this is how we do the calculation. So let us finish here.